Okay, everybody, good evening and welcome to our ongoing 2021 series of reliability webinars. My name is Jim Kelly and I'm the chair of the META Asset Management Society of Engineers Ireland. This is our 10th webinar of 2021 and I'd just like to say thank you to everybody this evening for taking the time to join us. I'd like to introduce our speaker tonight, Jerry Larkin. Jerry is an asset management and reliability engineering specialist with extensive experience in process and pharma industries in his 30+ year career. Currently, Jerry's with ESS, where he's doing a number of assignments in consultancy and training, and especially in the field of reliability engineering. Jerry is a part-time lecturer in maintenance and reliability in the BSc course in process engineering in CIT, and he's a former winner of the GE Landsteiner Award for root cause analysis and a former winner of Engineers Ireland's Smith Testimonial Award. Jerry is also a very proud member of the META Asset Management Committee, and we're delighted that he's with us and has been on the committee for many years. Tonight, he's going to talk about a subject that's probably close to all our hearts, treating failure with success. Well, I haven't really treated failure with success myself ever, but I hope after tonight I will be. I'm not going to give you the great detail of what this is all about, but what I will say is that I think we're going to hear a slightly different angle about how failures occur and how we should actually do root cause analysis, the different ways we go about it to ensure that we have success. Okay, so without any further ado, Jerry, I'll let you take the wave, and if anybody has any questions, if you look at the bottom of Zoom, there's a Q&A tab. If you want to type in your questions during Jerry's presentation, we will then go through them at the end. We'll probably take an hour to do all of this. Jerry will speak for about 45 minutes, and then we'll have 15 minutes of Q&A. And Paul Phelan from the Asset Management Committee will also MC that for us tonight, okay? So Jerry, you can take it away and best of luck.
Very good. Thanks, Jim. Okay, good evening, everyone. I'll just give an overview to begin with. What we're going to do is look at how failure has been dealt with in the past. We have to go back to the Stone Age, I think, to actually to make our start. It's a whistle-stop tour. So we're going to compare and contrast different approaches to failure in two strands. One is industrial maintenance and the other is health and medicine. So there are successful strategies, especially in health, that we can look at, and we're going to have maybe five or six useful takeaways at the end of the day. Basically, it's we're going back in time. It's a journey from then to now, and we're looking at it at a high level, and that's the kind of the whole presentation is built on looking at two levels. One is at population level, dealing with failure at population level, and the other is independent single units of equipment or whatever. So the introduction is basically is the tour. So we'll do 1 and 2 will be industry and human health. Then we'll go into sources of failure, reducing failure in areas and systems that would be population level, and then drilling down into root cause analysis. And obviously it's not a deep dive into root cause analysis, but there are some very, very important things that I think is for us to take on board in all of these sections. So okay, so a failure, generally we're talking about a failure event, a failure as an event. So events have contributors and events have consequences. And this is a simplistic model of an event, and you can take it as a failure event. So right now, a failure event happens. There were contributors, there will be consequences. One of the consequences of it is that, sometimes there is failure analysis done. The problem is the failure analysis isn't done in the time field that we see there when the failure happens, and that then causes a lot of we're into known unknowns, known knowns, and all this business, which we'll deal with in the presentation. So the simple model, or simplistic model, is something like this, where we have a lot of events, we have connections between the events. So it's modeled almost like a network. So there's the past. Here we are in the present, right today, and then we have the future. Now, if I just go to the next slide here, this is a sequence of events. So this is the sequence of events of a particular failure, and it looks like a sequence of events, but that is only known after the root cause analysis has been done. There's a lot of events that have nothing whatsoever to do with the failure, and there's a lot of clues that could lead us down the wrong direction as well. So it's quite a complex root cause analysis is something that you need to prepare well for. So you can see all of these events, they can be classified into causal event. Obviously, the failure event is the first thing we're familiar with. There may be a triggering event, and you have all these routine and some contributing events. The causal event is people will tell you you have to go back to find the causal event, the root cause event. So that's the earliest in the thread of events, and that is patently not true. And it's not true in principle, because this event that we have tonight is a webinar. If we were to go back to the true root cause, if we're going to say it's the earliest, then we would say the root cause of this event was the Big Bang. So that's a bit ridiculous, okay? But generally, going back to the earliest event is not necessarily the causal event, because there are a lot of things that we don't know and we have yet to find out. So that's just a simple model of a sequence of events. So we also have a situation where two events might occur concurrently, at the same time, and it makes life very complicated. Now, here's a situation where there were two events. It was a confluence of events, and I'm just showing this as an example of where this presentation is going to go. This was, it's a benign event. It's not a failure event. It was in 2018 when we had a very, very hot summer. And if anybody is listening or looking at this from abroad, I'm not sure, but I know in Ireland, it was a very, very hot summer. And that combined with the fact that a lot of people were using drones. Drones became popular for the public in 2018. They were accessible to the public. So some people, the leaders, were getting drones and using them, and they started finding what you see on the left-hand side. What you see on the left-hand side is an archaeological site that wasn't previously known about. And it turned up because of the fact that the grass was greener directly over the walls of that structure. So the drones found so much more archaeological sites. It was a bounty. It was a big dividend from the drones. And what I want to do is use that. That's a very, very powerful concept. And if you see in the bottom of the slide, basically, if you survey the topography, you will have a better idea of where to drill down. And that's true of a lot of things we do in asset management, especially root cause. But generally, if we're chasing a problem, we need to take a break. There are good reasons for that, which I'll explain later. So I just put this together as a kind of, not a logo, but looking from the top down, we need to do it when we have complexity. We need to get out of our zone. So survey topography and then drill down. And I have a little icon there as well with the T. The top of it is drilling wide at the top, from the top, and then drilling deep down below. So now we're going to go on our little journey, and we're going back to the Stone Age, and we're going to come up to now, and we'll see, what we'll find in doing that. And what I want to do is swoop down and pick up those little nuggets and sweep them up into takeaways. So, so first of all, we're talking about industrial failures, or what came to be industrial failures. That's the first strand. So the Stone Age. You can see there, flint. Flint was made into tools. It was easy to do because of the laminar kind of structure of flint. It was flaky, and a small little impact would give you a sharp object. You didn't have to go grinding because they didn't know about grinding then. So they made rudimentary tools. And funnily enough, there were people who chose to stay near the resources. So they were the settled communities, and then there were the nomads, and the nomads had a lower threshold of tool failure because they had to travel, and when they had their tools, they didn't want their tools to deteriorate because they wouldn't be able to go to the hardware store. So they needed to produce the tools with skill, and also workshops emerged as well for making those tools. So that's to my mind, it's the start of failure, because the nomads blamed their tools for the failure in much the same way as all artisans do. But also, to my mind, also this is the start of industry, because the whole sequence of raw material, process, use, maintenance and replacement, and that cycle, I think it seems to me where all that started. So then, coming fast, quickly through, we had the Stone Age, the wheel being invented, lubrication, wheelbarrow and machines, and then of course theoretical engineering, the Enlightenment, science, Newton, Da Vinci and all that. And then we had the Industrial Revolution. Machinery became more complex, corrective maintenance emerged. The equipment, the machinery was more complex, the duties were heavier, the speeds were higher, and so there was an exponential increase in catastrophic failures. And you can see that poor gentleman standing by. I think it must be a boiler after exploding, and that's a huge event. And there were a lot of those huge events during the Industrial Revolution. So regulation came, and then of course preventive maintenance as well. And then we had the early 20th century, and Ford is kind of the classic assembly line, minimizing failures through preventive maintenance routines. But also they had car manuals, and they passed on the maintenance of the cars to the owners of the car via the car manual. And so asset care developed there as well, but mostly preventive maintenance. So, and then of course now we have reliability centered maintenance, which to my mind is focused on failure. That's what we're talking about here, but I think maybe we should have been talking earlier about what we're going to talk tonight, because we are so obsessed with failure. We're drilling down into failure at deep levels, and maybe the time has come to come back out. Reliable, or TPM does that to a certain extent. It's more holistic. It's a cultural thing. And then we have ISO 55000 as a standard. We have Industry 4.0 and all what we know now in terms of big data and all of that. So that's the end of this strand. And then we go and we're back, 5,000 years. We're going back on the health journey. So how did they treat failures? Back in 5000 BC, basically people didn't know how to treat. Maybe it was the basics, stopping bleeding and stuff like that. This now is what history tells us. That we don't know very much about those early periods, but there is evidence around 2000 BC that illness was being treated, herbal medicine, cauterizing, use of splints and all of that around that time. And then we had the Greeks, bless. And so they came along, and the terms I'm using, I'm importing from asset management. So when I talk about corrective medicine, it's it's like corrective maintenance. It creates a corrective maintenance, preventive medicine to preventive maintenance, and so excuse me for using these terms, but I'm bringing it into the health stream just for simplicity. So we had corrective medicine, preventive medicine, we had total productive medicine, Hippocrates, we had the Renaissance, which was reliability centered medicine, and then we had the big boom in terms of treating failure in the health domain, and that was positive health in the 1970s. So here we have the Greek goddesses. There were 5 sisters. 2 of those were Panacea, who was the goddess of corrective medicine. That term wasn't used. I'm just applying that term. But Panacea advocated that illness and disease could be cured by corrective intervention. Now, it wasn't a philosophy of using corrective medicine alone. It's just that the Greeks developed a balanced approach, strategic approach to dealing with health and health issues and illness by having 5 sisters, and 2 of those were corrective and preventive. The other 3 were related to the process of healing itself. There was recuperation, and the last one then was about shine, what 5S would call shine. So there was Panacea and Hygeia, and this was 1000 BC. Hygeia represented the belief that people would be well if they adopted a healthy lifestyle. Now that is common sense. And so they were very far ahead, obviously, of industrial treatment of failure, but it's interesting to see that they had gods of that were dealing with corrective and preventive. This is the guy, Hippocrates. Again, I'm calling it total productive medicine, but he had the holistic view that illness is an interaction involving the patient, the disease, the healer, and the environment, and the process of treatment must involve all of these. And more than that, he believed it was dynamic. So he was looking at not just the fact that there was a spectrum, in a cohort of patients. There were patients who had more or less resilience. The disease itself, there was a spectrum in terms of the virulence of the disease, whatever it might be. And then we had the healer, and obviously there will be differences and variation in between some healers in terms of their skills, and then there's the environment, that some people are exposed to different environments. So he at the time, and not alone in their individual domains, but the interactions between all of those, he was allowing for those. He was advocating that those dynamic interactions must be part of the healing process. So I mean, that is really I'm not sure that in some cases we're doing that in asset management, but we'll go through that later. So then we have what I'm calling reliability center maintenance. So back 450 BC, we had Hippocrates with his holistic approach. And now we have the Renaissance, and of course we had the technology at the time was developing, science was developing, and so it drew the experts, the people who were treating health and illness downwards into the individual and into their components. And so, they were broken down, more knowledge was garnered about all the different components and their interactions, and then they were treated. That was 2000 years after Hippocrates. I suppose I'm a little bit skeptical about RCM or reliable, in terms of going too deep and, sort of without also going back up to the high level. So, but in any case, there is reliability centered medicine. So now we're coming up to quite recently, and this really was a paradigm change, a big step change in the treatment of health. So a guy called Mark Lalonde, he was a Canadian Minister for Health, and he looked at it differently, and he was tired of treating the patient and looking at the components and drilling downwards. And he did advocate for new technology, for surgical skills and all of that, but he did also say, he had a brainstorm and he said, well, where are the sources of these failures? We won't be able to eliminate or significantly reduce failures unless we know the sources of the failures. So in much the same way as I'm bringing in another arena here, but criminal, when a crime is committed, straight away we're looking for forensic evidence to make a case and convict the criminal. But oftentimes that doesn't work well. And there was a time back in Ireland some years ago, 20, 30 years ago, when it didn't work well because they couldn't get the criminal because of intimidation and all that. So what they turned to was following the money. And that's how they actually got these criminals at the end of the day. In much the same way Mark Lalonde was working in that area. Like instead of, he believed that all the treatments, working on individuals aggregated together is not enough. And so he went up to survey the topography, and he said, I want to define the 4 fields where the failures are coming from. And he wanted to make something robust. And so he had 4 fields. And the 4 fields were genetic and biological factors. And this is not in order, not necessarily in order. So then there were lifestyle factors. In other words, the person themselves, how are they treating their own bodies and minds? And so there were lifestyle factors, there were environmental factors, which is patently obvious. And number 4 was the accessibility and standard of health services. So I think that is really like the medical field of health promotion and positive health thought it's so good that WHO adopted it, and they came in as a result of that with a new definition that health is a state of complete well-being and not merely the absence of disease or infirmity. Now, if we look at that in our field, we would say that failure or asset condition is not merely the absence of failure. And so there are correlations there that we could use. And we'll go into that. But I think the 4 fields there's only one word, and that's elegant. And that's where positive health came in, and they looked at a lot of areas. Aging, for instance, was about adding years to life or adding life to the years you have. And that's something we could import as well. So I'm swooping down into this, even though we're breaking into a new section. And okay, the new section I'm calling sources of failure. So now, if you'll indulge me with this slide, I think a lot of you might have seen this slide. The one on the left is the opportunity to reduce failure. And this is in the life cycle of an asset. And so I don't have procurement in there, but it should be in there. So there's procurement or spec and design, installation and operation and maintenance. And the opportunity or the probability of increasing reliability is very low when you're in the useful part of the life cycle of the asset. So here we are, we're saying maintenance is Kaizen. And I've spoken to Sensei, and they say when you have good definition, then and you're working well, your maintenance crew is working well, and the organization is working well, and they could do this because they had TPM, which is very holistic and culture driven. And they say maintenance is Kaizen, and I can imagine that it would be if you were a piece of equipment and you were screaming and there's a lot of friction on your left arm, and you're hurt and you see somebody coming with a toolbox, it is improvement. You are going to be delighted to see that person. At the moment, in a lot of companies, And I've seen good companies that have good maintenance where the operators are looking at the toolbox and the person carrying it and saying, oh my God, here we go again. He's saying it a lot of the time because there are a lot of failures. The poor guy with the toolbox is a good guy. His tools are, he has the tools, but because the source of failure is not within his domain, he can't do very much about it. And that's what's happening on the left. This on the right is something I did looking years ago at where the sources of failure were coming from. And I looked, and this is for a production and a finishing departments where the reliability issues were coming from. And it's a bit clumsy. There are materials in there, organization is in there, equipment interfaces, process loading, design installation, inherent equipment. And even that inherent equipment, 34%, because the equipment is the host. It's like the human. The human is the host for the pathogen. It doesn't mean that the human is to blame for being sick. In the same way, equipment or processes are hosts of failure, but we look at maintenance and the toolbox as the first line to fix the failure. And if they don't, it's a disappointment. It's a disappointment with them, and it's a disappointment because we haven't identified the sources of the failure. So no, mapping the 4 fields, Lalonde's 4 fields, to our arena, we'll say, and I'm calling them, you see in the top, 4 failure fields. You might choose to make it 5. You might choose in number 2, I'm including raw materials. You might choose not to. But in principle, I think this is so elegant and so robust that if we spoke with the one language, the problem is we're all saying different things. Most of the failures are coming from people issues or come from organization or whatever. If we all adopted something like this, the 4 failure fields, you can see it will not affect root cause analysis. We'll still do root cause analysis, but if we really want to chase failure, like who were they? CAP, was it? The Asset Bureau, who were they again? The Criminal Asset Bureau. CAB followed the money. So if we followed where the costs were coming from, and if it was classified as elegantly as this, we would get a big improvement. And I'm saying, for instance, we should have in a given area, if we're doing improvement initiatives, the standard and accessibility to maintenance might be one project, but if we started off doing 4 projects in the one area, and each of those teams had some commonality, you'd see a huge improvement. So this is really important. So you can see on the top there's a T. This is one of the main takeaways. Now, okay, so now we're into reducing failures at population level. Okay, so I'm suggesting, and again, this is a takeaway, DMAKE is a great structure for it. Defining failure codes, it's usually in the CMMS, Maximo, or whatever you use. Measuring is about the number of events, maybe, or downtime, or costs, or all 3, or some kind of aggregation of all 3. And then analysis. Now, I started off my career looking at acute and chronic failure, but I think we're missing something, and that is, 3 classifications. And the reason I'm saying 3 is because in GE Healthcare, the logistics people deal with 3 or say the orders, and they look at runners, which are there all the time, repeaters, which come in periodically, or not necessarily periodically, but maybe sporadically. They mightn't have a regular period, and then strangers. So if you look you look at severity occurrence, so what's on the runners, for instance, they tend to have low severity and high occurrence, high frequency. They're kind of tolerating. There's always a base level of these running failures. Strangers, then the opposite case, is where you don't know the day or the hour. These are 1 in 20-year events or whatever. They don't normally happen. The problem is, like, you don't get fired for one, but two is unfortunate. If you get the same of these type of failures in relatively quick succession, it's unfortunate. So there we have high severity and low occurrence. And then there's the repeaters that are not high in any of those, but they're kind of tolerated. So if you classify in those three, then you can do some very good analysis. Improve, obviously. You can see that prevent failures at two levels, individual and population, and that's really, really important, because if you're looking at a small number of assets, you know, and you're going down to individual level, you might be doing root cause. You will take if you know, in terms of the Pareto, if you do a Pareto of your root causes, we say, and you address the top 20%, that's fine. You do that at individual level, but you're missing a trick, and that is the insidious failures that are happening here and happen also right across the company. And I have a good idea. You can go into a small area, you're looking to do the significant for you know, for the client, you want to get the significant failures, but you will always find down along a noise level of certain things, and the more you go wide, they're still there. So one of the big ones is kind of looseness, you know, in terms of sensors, vibration, looseness, alignment, or sorry, misalignment, I should say. So in that zone of misalignment, looseness, vibration, you generally find it in a small system, but actually it's happening right across the organization. And while you might have got the two biggest issues in that zone, you'd be missing a trick, because the other ones are small but are site-wide, and you get a huge dividend from that. So looking at it, you might be in there to look at the individual at deep level, but you should also look at a wide, drill wide to the population as well for a dividend. And then we have control. So that's, I think it's good to do it in a DMake structure. This is another one where we could benefit by going up. This is a failure, a downtime event. And so this is time. You can see plant up, plant down, the time it takes from plant down to plant up again, and it's quite significant, depending, you know, I mean, if there is a handover, if there is an isolation, say, involved in the handover. So there are elements in that, you know, sequence of events, we'll say, or whatever. The actual repair correction might be small in comparison to the whole downtime, and so if you go and you'll make a marginal improvement by improving the correction time, reducing the you know, by skills, better skills or better allocation or whatever, but you're missing a trick, because you can take one of the escalations or take the allocation, take any one of those slices, treat them site-wide if you think that there is a particular problem, and you get huge benefit in terms of the whole downtime being reduced. So again, we have survey, topography, and then drill down. This is typical then of an investigation plan, where you go in and do work. Again, you know, in their identify drill wide opportunities, because generally the client doesn't expect it, and it's something that you're doing in your sweep up. You find those anyway, and so that is a typical failure reduction project. So now root cause analysis. Okay, so let's go back to Hippocrates, and we'll apply his logic to root cause analysis. So if we say that the process involves four components, there's the asset process. Okay, so I mean the industrial process, the process that you're investigating, the process that failed or the asset that failed. There's the failure itself, the failure mode itself, we'll say. And then there's the environment, and there is what I call the driver. I'm calling it the driver because it might be one person doing fault finding, or it might be the team leader doing a root cause investigation. So the driver is the only one of those components that can control and influence, for good or bad, the outcome of the root cause analysis. So the driver must be aware of how they can influence the outcome for the better, and they can. I presume the driver has some knowledge, or if he's the best mediator, then that's fine too. He can pull all the heads together. But the driver must know how to get a good result, and you can bring it in your favor. So you can load the dice. One is rigor, and that is about selecting the right tools and structuring the investigation well. There are good structures and there are not so good structures. There is a most efficient way of using the right tools, and we'll get into that. I'll just touch it at a kind of a high level. But also creativity. Creativity is very important. Customizing tools and by association, and it's really, really important. And we'll get into that. But luck also. The thing about this is, I've always found that there's some element of luck. It's improved and increased if you have a good relationship with people near the source of the failure. And by that I mean operators, technicians. And I don't mean for this investigation. If you cultivate a good relationship with the operators, the product builders, the technicians on the line, supervisors, you will find that they will come to you with nuggets, because something similar might have happened, a near miss, we'll say, 2 weeks later, and they will be ringing you to say exactly the same thing happened, except it didn't have the bad outcome. And this is what happened. So it's very important to, luck is very important, but you can make it happen because luck is the dividend. So fortune favours the prepared mind. And if you do the rigor and creativity, you will find you will get lucky. So this is selecting the right tools. Normally, the conventional order, you can see it on the left. I'm getting no feedback now, so I'm presuming everything is going okay. But this is the conventional order of the root cause toolbox. And you'll see A3s, and you'll see, good organizations, it's kind of looked at in that order. This is only in the order of how easy it is. The fault finding relates to technicians generally, fault finding and finding the problem before it's ever escalated. Sometimes it has to be escalated. And then maybe somebody does the 5 whys. That's a little bit more difficult, but it's still relatively easy. So these get more difficult as you go down, and this is the way it's generally ranked in the A3s. So then you have your Ishikawa fishbone diagram, then you have the fault tree, and then you have the big bazooka, in some people's eyes, the FMEA. But that is only I don't think it's configured properly. So this is my attempt to make a logical configuration for all this, and also in line with the theme, I suppose, of this presentation is survey the topography before you drill down, because you will be drilling in the wrong places. And so that is why I'm putting the fishbone at the top. You can do a cursory fishbone in your head. Generally, you take a few people, but you can still do it on the run. It doesn't have to be a huge desk-bound exercise. So I'm grading it then in terms of breadth and depth. Okay, so the fishbone is top because it has the highest view. It's a look down. It's top down. So it's wide and not deep. Fault finding is relatively deep. We're getting deeper with 5 whys. Fault tree then is the deepest and the most thorough in terms of deep dive. This is it, or event analysis. But and then we have the FMEA, and sometimes FMEA is used for root cause. Many issues are treated, but the root cause is relatively shallow. And I know it confounds the logic here to have it down at the bottom, but its place is in the bottom really, because this is a bottom-up exercise. all of these are deductive, they're top-down, fault finding, 5 whys and fault tree, but this is inductive, it's bottom-up. And the reason that the root cause is shallow is because you have a team of people and their energy is divided into defining the failure mode, the cause, the effects, the risk, and the treatment for that particular failure that you're treating. So in terms of the energy you're putting into it, it's only one of 5 criteria. And so it's not a deep dive root cause. You might find that for some of the rows you're treating, you may need to go deeper. So that is a better configuration, I think, for root cause tools, and it gives you a handle, and especially you can do, as I say, the Ishikawa. It's still better to have a few people doing it, because then you're really going wide and you have different expertise in there. So then we have customizing the tools. There is no legislation that tells you how to root cause, or there are suggestions about particular methods, but you can do hybrids. And if you're confident and you're doing root cause, this is something you can do. So in this particular case, it was a real fault tree, but then it started going wide as well. So like the fishbone headings were configured, like materials was merged with measurement. It was a heating system, and the measurement would be temperature and pressure and all that. The method included people as well, and the heating system itself included in environment. So like we had actually 3 fault trees, but the top 3 were the elements of a fishbone diagram, and then we combined the 2 and we got a good result from that. And finally then, this to me is the most wondrous, because not many people know this. Okay, it's by association, and there's 3 little paragraphs there: a blending of elements drawn from 2 previously unrelated arenas into a new concept, the mental association of an idea or object from 2 different fields, the creative leap made by the mind that gives rise to new and startling perceptions. It is absolutely unbelievable. When you want this to happen, it will happen. Not always, but it is so powerful that okay, so I'll just give you 2 examples. George de Mestral was the guy who was looking for a new form of zip or button. Like, he knew about zips, he knew about buttons, he knew about the duffel coat and all that, but he was looking for something different. And one day he practically gave it up, or at least he wasn't thinking about it, and he was out in the countryside, completely relaxed. And when he came in, he found that, I don't know what you might call them, but I call them sticky backs. When I was small, out in the fields, the little spherical balls that come from certain plants, and they're sticky to touch. And he came in and he found there were sticky backs sticking to his trousers. And when he started pulling them away, he made the connection. My God, this is what I want. It's this amount of ease, and this amount of adhesion and this amount of ease to open. And he came up with Velcro as a result of that. He put the sticky backs under the microscope. He put the fibers of his trousers under the microscope, and he saw how it actually functioned. That the strands were stuck together, engaged together, say, and by merely pulling, lightly, they tended to stretch and then separate. So, and then there was 3M, which is a great story of a guy. I'm about 3 more minutes now. A great story of a guy who was a chemist in 3M's lab. 3M are a huge corporation. They make big, huge mining machinery. It's the Minnesota and Minneapolis Mining Corporation. And for some reason, they got into, duct tape as well, Scotch tape as well. So, but the brief was to make a glue stronger than Loctite. Or Devcon or Loctite, one of the 2, that was easy to apply. And so he worked for years, and eventually he came up with the ideal solution. And so it was a solution, it was a recipe, he mixed it together, and cooked it, we'll say. And when he opened the oven, when it all came out, it was the most useless glue that man had ever created. It was viscous, it was clear, it was like glue, but it just didn't stick. And he was very, very put out. But he was working for the company, and the company allowed 15% of the person's time for their own creative projects. Now, obviously to benefit the company, but they had 15% of their time to do, kind of not off the cuff, but creative work, we'll say. So he then started looking in that time for an application, I suppose, to justify all the time he spent on it. Eventually he gave up and he was going to die, a sad man. But his brother was in a choir, and sometime after, he invited him up to hear him singing and see him singing. And he was singing, and in the book where the hymns were for that particular service, he had them marked with pieces of paper or whatever, and then he got into a bind because when he was flipping it over, the paper would fall off, and he immediately made the connection between the piece of paper and the glue, the useless glue that he had created, slapped it on the piece of paper. His brother was delighted, all the choir people were delighted, and all the other choirs everywhere were delighted when he went to 3M and said, this has potential. And it's now the biggest seller of that huge organization, the Post-it note. So there are two examples of, by association, you can actually almost order it up for yourself. So here we have RCA. We often need to rationalize latent events with black box processes and sporadic connections. Sporadic connections, they're the killers because they're events that happen but are not continuous. So when you're doing your trial of what you think is the root cause, you may be disappointed because of that, because the connection is sporadic in time. And so we have to deal with all that. It's very, very difficult. Root cause is very difficult, but pending, waiting for good computerized kind of analysis, we have our own resource, and that is the mind. And I can tell you from my own experience, and I've spoken to other people in this arena, and they feel the same. When you really, I was changing jobs at one stage, and there was a problem, and they were delighted to have me because I was a reliability engineer. And they wanted me to do a root cause. And going into an unfamiliar environment, it's very difficult, and you weren't familiar with the equipment or the process or whatever, and yet I had to hit the ground running. And I really it worried me, to be honest. But I found when I got there, I had, a day in the place, and I had a solution the following day, because I won't say I woke up bolt upright 3 o'clock in the morning, but I found the solution in a black box situation where I couldn't have known the detail really deep down in terms of the process and the equipment involved. So it does work, and I've seen it working since. And the reason for that is because you want to find the solution, and there is something in the mind, some kind of an energy in the mind that kind of coalesces your energy into this. But it works in a kind of, as far as I can see from my own experience, under certain conditions. And that is when you're not thinking of it, when you're not consciously thinking of it. So I'm positing that bisociation is innately suited to the synthesis stage of RCA because it generates previously latent connections. You don't know that these exist, but the iterations that go on in the neural networks, because the networks of failure are something similar. And I'm only speaking at this point in time. Somebody will come up in 10 years' time and say there are no neural networks. Maybe it's like the way the atom is modeled, it's all probabilistic and all this business. There is something in bisociation that helps you in root cause. And from my own experience, it's happened a lot of times. It doesn't come to order, but it does come. You have a better chance of it happening. And this is the process. What I'm suggesting for people, the drivers of root cause investigations, The first thing is you must immerse yourself and understand the failure in the environment. Obviously, you do need to know this yourself, because if you don't know it, if you haven't absorbed it, then the brain is working on empty. So you don't necessarily have to have the deepest knowledge, but you must have sufficient knowledge. You have to allow some incubation period for unconscious processing, and that's very important. So the way to do that, to my mind, and this is what I've done, is instead of having a crucial killer root cause investigation event, just say it might be 4 hours. You schedule 4 hours, you have all the right people in, you've got a good lot of evidence, and you're going to have it done in 4 hours, subject to some clarifications here and there. What I'm suggesting is don't do it that way. Break up those periods, allow some incubation period for unconscious processing. And what happens is, more often than not, on the second session, not just you, but other people will come up with things that they would not have come up with in the first session if they merely sat for another 2 hours. You have to come back, you have to go away, do your walk or your hike or whatever it is you do, and come back to it. And when you come back to it, these latent issues come up. So the bisociation link will come when least expected. Now, when I say allow some incubation period, there's a difference between incubation and rumination. Rumination is conscious processing, and generally it's bad because you're obsessing with something. This is not rumination. It's not trying to think it out. It's coming back. It's going upwards. Again, you're kind of looking at the topography. You're not going down deep. You shouldn't be thinking of it at all. So that's that. Okay, all right. So I'll leave you with this. Anybody who's looking for this presentation, my email address is on the end slide, which I'll be showing you now, and you can come back to me if you want to get copies of that, and you'll see this. But basically what I'm saying, and really, really emphasizing, is that the root cause does not define the failure. Whatever failure event you have is not defined by the root cause, it's defined by the failure mechanism. That is the causal event and the path it takes to get to become the failure that you experience. Because if you merely find a root cause, it could well happen it could find another path. Because the root cause might not have been the dominant root cause, and so you do have to find the failure mechanism. This was an initial event, it led to this, it led to some omission, somebody wasn't doing something or whatever, and then you have the failure event. So the failure mechanism is what I will always put into a report. It's not complete without the failure mechanism. And this then is broadly what you should be looking at. So takeaways then, this is the big one. I think in all your how do I put it, endeavors in life, it's good to go up, to survey the topography before you go drilling down. In other words, I mean, somebody comes up with that recently for decisions, making important decisions. It's an anagram called STOP, and so this is similar to that. It's kind of just go up, come up, to look back down again. So that's the first takeaway. Then we have this, which is huge. I think everyone here, I would like to think that a lot of people here will go back to their places of, and I'm not talking just about maintenance people, but when you see it in like that, let the maintenance people go and address their standard and accessibility to maintenance. But here, for instance, say legacy, not everybody has that circle, that virtuous circle, that at the end or near the end of an asset's useful life, that you're coming back to the front end and feeding the experience of that, where applicable or where relevant, into the spec for the replacement. And so it's very important that you make a loop of that, and then you won't have those legacy issues, because those legacy issues contribute an awful lot to the issues that we have at the moment. Each of those fields is a field and is our sources of failure, and we should be looking to address those. If if there is one vision, I think it's the vision of CAB. For all the fingerprinting at the crime scenes and all the interrogation and all of that, they had to follow the money. And what we should be trying to do is follow to the genesis of the failure. And it's not what happened in the machine. It's the 4 fields, and we'll call them the 4 failure fields. And all you people should go forth from this time and place and bring that back to your organizations. The next one then is simply just applying DMAIC at population level for improvement projects. The next one is it's a downtime event, but the repair or correction may be proportionately a small part of the whole downtime. And then you have bless him, Hippocrates, and the holistic approach to an endeavor, we'll say. And for this purpose, it's root cause analysis. This person, the driver, is the only person that can significantly affect the outcome of the root cause analysis. And then we have by association, and that's it. Thank you very much.
Okay, Jerry, listen, that was really good. Paul, do you want to take us through some Q&A now? And we're right up against the time, so maybe just a couple of minutes, maybe 5 minutes, and then I can close it out.
Well, indeed, yeah, and just thank you very much, Jerry. Diverse range of topics there. I probably would never have grabbed Hippocrates and Greek medicine to draw the parallels of root cause analysis, but you have that gift, I guess. So I'm going to ask you one question from Colin Heavey. How would the approach of root cause analysis downtime events on an automated line that is made up of robots connected by a conveyor? That's a tough one to start with.
Okay, so I got the robots and all that, but what the initial part of it, how could?
I think what he's trying to say is, how would you approach doing a root cause analysis on an automated line that is made up of robots connected by a conveyor?
Okay, I think that I don't think the process would change. I mean, you'd have to get the disciplines, the various disciplines involved. And it is complex, and I know it is complex, but the same things apply. So like, I think fault tree, because it's so complex, a fault tree is probably the best way to do it. If you're looking at FMEA, it's much broader. You're taking in all of the failure modes. Whereas are you saying that if it's the case that you have a particular failure and you want to look at that, you would do a fault tree. If it's a case that you want to find out all of the ways it'll fail and then do a Pareto of that, it would be an FMEA.
Yeah, no, I tend to agree. No matter how complex the situation gets, the principles remain the same as to how you approach it. So I have one question here from Eamon Kelleher. It says, "Hi Jerry, I can appreciate your thoughts on the incubation period, but do you think that a rapid response directly after an event is also a way to go, where the crime scene is fresh, so to speak?"
Yes, it is, and I'm not advocating anything other than, especially the model. If you saw the model where the present was presented as a plane, like if you're close enough to that plane, then you are really, really way ahead. Ideally, what should happen is everything should be frozen. So if something happens, clear people, only the people who can actually document what has happened in the recent past. The closer you are to the event in time, the better your root cause outcome is going to be. And it's really, really important. Definitely, you do have to do that and get there fast to do that. What I'm talking about is controlled root cause, where you collect the evidence over a period and then you have the root cause event when you've amassed enough evidence to get all the people together and to have that interdisciplinary engagement.
Okay, great. I think we'll finish off just one more question from John Coleman. Many, if not indeed most, equipment failures are mainly driven by poor original design or abuse. such as operating well beyond capacity or incorrect operation by poorly trained operatives. With this in mind, is the detailed analysis worth the effort, as no amount of analysis or knowledge will correct poor original design?
Well, but that's what I'm trying to do, is get people to say, right, chase the sources of failure, define what they are, and we have now 4 fields of failure. So if we were to do, say, an exercise on the top one, legacy, then it's about documentation. It's about going to. We can't do anything right now, but for the next piece of equipment or whatever, it's like a cultural thing across the company. We could say we need to do our specifications better. We need to spec for reliability, spec for maintainability, and all of that. Like, you're dead right, as in the graph. The opportunity for improving reliability when you're operating and maintaining a machine is very, very small. So it's about good procedures. And if, like, the very fact that you're having trouble in there and you have legacy issues, what I'm saying is go back and follow the costs, because that's causing you excessive cost. And you need to follow that, not drill down into the machine, but follow the costs into the 4 fields.